The mission that knew how it would die. Some missions end because something breaks. Cassini ended because it succeeded too well. From the very beginning, NASA engineers knew exactly how this story would finish, even though the ending was still 20 years away. Cassini was never meant to return home. It was never meant to drift quietly into retirement. It was designed to die deliberately, on purpose, at a specific moment, in a specific place, for a very specific reason. That alone makes Cassini unusual. Most spacecraft fail unexpectedly. Cassini did not. It executed one of the most carefully planned deaths in the history of space exploration, and the final images it sent back were not accidents or afterthoughts. They were intentional, calculated, and emotionally heavier than anyone expected. In September of 2017, after 13 years orbiting Saturn and nearly 20 years since launch, Cassini made its final dive. It plunged between Saturn and its rings, threading a gap no spacecraft had ever attempted to cross before, transmitting images and data until the signal was physically ripped apart by atmospheric friction. Those last images were not just beautiful, they were unsettling. They showed Saturn closer, sharper, and stranger than we had ever seen it. And as the signal faded, something became clear. Cassini hadn't just changed what we know about Saturn, it had changed how we understand planets, moons, rings, atmospheres, and even the conditions for life itself. The shock was not that Cassini ended. The shock was how much it still had to say at the very end. Why Saturn was never just another planet. Before Cassini arrived, Saturn already felt familiar. We had seen it through telescopes. We had flown past it briefly with earlier probes. We knew about its rings, its size, its iconic silhouette. Saturn was beautiful, but it felt solved. A gas giant with rings. Majestic, yes, but predictable. Cassini shattered that comfort almost immediately. When it entered orbit in 2004, Saturn stopped behaving like a static object and started acting like a dynamic system. The planet's atmosphere revealed storms that dwarfed anything on Earth, including a hexagon-shaped jet stream at the North Pole that should not exist according to standard fluid dynamics. The rings, once thought to be ancient and stable, turned out to be active, evolving, and possibly temporary. Cassini showed that Saturn is not just a planet with rings, but a gravitational engine that constantly reshapes everything around it. Moons exchange material with rings. Rings rain particles into the atmosphere. Magnetic fields twist charged dust into invisible structures. Saturn became less like a planet and more like a living system, and that realization only deepened as Cassini continued its long mission, revisiting the same regions again and again, watching changes unfold over time. This was not a snapshot mission. It was a slow conversation with a world that refused to sit still. Cassini was not cautious in the way we usually imagine spacecraft should be. It was curious to the point of recklessness. Over its lifetime, it executed dozens of close flybys of Saturn's moons, some at altitudes that made engineers deeply uncomfortable. It skimmed through plumes erupting from Enceladus, a moon that should have been frozen solid, but instead sprayed water vapor and ice into space. It mapped Titan, Saturn's largest moon, revealing lakes, rivers, and seas made not of water. Cassini turned moons that were once geological footnotes into primary targets in the search for extraterrestrial life, and with every discovery, the stakes rose. The more Cassini revealed, the more dangerous its continued existence became. If Cassini were ever to lose control and crash into a moon like Enceladus or Titan, it could contaminate environments that might host life. That risk forced an uncomfortable decision. Cassini could not be allowed to survive indefinitely. Its ending had to be deliberate, and that ending would also become its most daring phase. The decision to sacrifice a perfectly functioning spacecraft. By 2016, Cassini was still healthy. Its instruments worked. Its power systems remained stable. There was no mechanical reason to end the mission. The reason was ethical. Saturn's moons had revealed too much potential. Enceladus, with its subsurface ocean and active geysers, became one of the most promising places to search for life beyond Earth. Titan, with its complex chemistry and Earth-like processes, raised similar concerns. Cassini carried Earth microbes. No matter how carefully it had been sterilized, letting it drift uncontrolled posed a risk scientists could not justify. So NASA chose a controlled descent. Cassini would be sent into Saturn's atmosphere, where it would be destroyed completely, ensuring no contamination of the moons. But engineers realized something else. If Cassini had to die, it could die doing science. That decision led to the most dangerous and scientifically rich phase of the mission, the grand finale. The grand finale was not a single maneuver. It was a sequence of orbits designed to push Cassini closer to Saturn than ever before. Over and over again, the spacecraft dove through the narrow gap between Saturn's cloud tops and the inner edge of its rings. This region was unexplored and poorly understood. Engineers did not know how dense the ring particles were, or how turbulent Saturn's upper atmosphere might be. Cassini flew blind into a region where a single unexpected collision could end the mission instantly. Instead of backing away, NASA leaned into the risk. Cassini's instruments were reconfigured to sample Saturn's gravity field, magnetic field, and atmospheric composition with unprecedented precision. The spacecraft was effectively skimming the planet, close enough to feel its pull in ways no probe ever had before. Every pass brought new data, and every pass could have been the last. The rings lose their mystery and gain a new one. One of the most shocking discoveries from Cassini's final orbits involved Saturn's rings. For centuries, astronomers debated their age. Some believed the rings were ancient, formed alongside Saturn itself. Cassini's data suggested something very different. By measuring how much material from the rings was falling into Saturn's atmosphere, scientists realized the rings might be relatively young, perhaps only a few 100 million years old. That means Saturn may not have always worn its iconic crown. The rings could be temporary, a feature that forms, evolves, and eventually disappears. This idea was deeply unsettling. Saturn without rings feels almost wrong, like Earth without oceans. And yet, the evidence pointed in that direction. Cassini showed that the rings are not static decorations. They are dynamic, fragile structures slowly being pulled apart by gravity. The final images captured subtle textures, waves, and disturbances that revealed the rings as active systems, constantly shaped by Saturn's moons and magnetic field. The closer Cassini got, the less stable the rings appeared. Beauty, it turned out, was temporary. Saturn's atmosphere up close. As Cassini dipped lower during its final passes, Saturn's atmosphere revealed details no telescope could ever capture. The clouds were layered, turbulent, and far more complex than models predicted. Chemical compositions shifted in unexpected ways. Cassini measured the mass of Saturn's core more accurately than ever before, forcing scientists to revise models of how gas giants form. Saturn was not just a scaled-up version of Jupiter. It had its own internal structure, its own history, its own rules. The closer Cassini got, the stranger Saturn became. The planet's magnetic field, previously thought to be nearly perfectly aligned with its rotation, showed subtle asymmetries that defied explanation. Even after years of analysis, some of Cassini's final measurements remain unresolved. Saturn, it seems, kept some secrets until the very end. The last images before silence. On September 15, 2017, Cassini made its final plunge. As it entered Saturn's atmosphere, it continued transmitting data in real time. The last images it sent were not dramatic explosions or fiery destruction. They were calm, detailed, almost intimate. Saturn's cloud tops filled the frame, banded and textured, closer than any human-made object had ever seen them. And then, gradually, the signal degraded. Atmospheric drag increased. Cassini began to tumble. And finally, the transmission stopped. The spacecraft was gone, vaporized in Saturn's atmosphere, exactly as planned. What remained were the images and the data, frozen in time. Those final images were not just the end of a mission, they were the last close look humanity would have at Saturn for a very long time. What Cassini showed us about time. By the time Cassini entered its final phase, it had already done something rare in science. It had transformed Saturn from an image into a timeline. Before Cassini, Saturn was a symbol, frozen in textbook illustrations and telescope photos. After Cassini, Saturn became a process. Storms were observed forming, evolving, and fading. Rings were seen shifting, thinning, and interacting with moons. Atmospheric patterns changed over seasons that lasted years, not days. Cassini didn't just show what Saturn looked like, it showed what Saturn was doing. Distinction matters more than it first appears. A static planet can be categorized and filed away. A dynamic system forces scientists to accept uncertainty. Cassini revealed that Saturn is not finished. It is still changing, still reorganizing itself, still moving material around in ways that defy neat explanations. This This realization quietly undermined many assumptions about gas giants. These worlds were once thought to be simple, massive balls of gas governed by straightforward physics. Cassini replaced that simplicity with complexity. Saturn became a place where gravity, magnetism, chemistry, and motion are constantly negotiating with each other. And in the final images, taken closer than ever before, that complexity became impossible to ignore. The strange calm before the end. There is something unsettling about how calm Cassini's final hours were. There was no emergency tone, no frantic correction maneuvers. Everything unfolded exactly as planned. Engineers had rehearsed this ending for years. Commands were uploaded days in advance. Cassini followed them without hesitation, as it always had. During its last orbits, the spacecraft passed repeatedly between Saturn and its rings, a region that had once seemed too dangerous to attempt. Instead of chaos, Cassini found structure. Subtle variations in gravity revealed how mass was distributed inside Saturn. Tiny changes in velocity helped scientists calculate the planet's internal composition with unprecedented precision. Cassini was effectively weighing Saturn as it died. This calmness gave the final images an unexpected emotional weight. The spacecraft was not fleeing destruction, it was leaning into it, using its last moments to answer questions no one had known how to ask when the mission began. The images sent back during these final passes were sharper, closer, and more intimate than anything Cassini had transmitted before. Saturn filled the frame, no longer distant or majestic, but immediate and overwhelming. The planet stopped feeling like a symbol and started feeling like a place. Saturn, without the comfort of distance. Distance has a way of making things feel safe. For most of human history, Saturn was beautiful, precisely because it was unreachable. Cassini erased that comfort. Its final images stripped away the illusion of distance and replaced it with proximity. The cloud tops appeared textured, layered, and restless. Bands blurred into one another. Storm systems hinted at forces operating far below the visible surface. Cassini showed that Saturn is not a gentle giant. It is violent in slow motion, governed by energies that operate on scales difficult to comprehend. The closer Cassini got, the less Saturn resembled the serene planet of popular imagination. Instead, it looked raw, unfinished, and powerful. This shift in perspective matters. When something is distant, it is easy to romanticize it. When it is close, it demands respect. Cassini forced scientists to confront Saturn as a physical system, not an abstract idea. And in doing so, it raised uncomfortable questions about how many other worlds we think we understand simply because we have never been close enough to be wrong. The rings as a countdown clock. Cassini's final measurements of Saturn's rings introduced one of the most unsettling ideas of the mission. The rings may not be ancient, they may not be permanent. Data showed that material from the rings is constantly falling into Saturn's atmosphere, a phenomenon now known as ring rain. By measuring the rate of this loss, scientists realized that the rings could disappear on timescales that are short by cosmic standards. Hundreds of millions of years, not billions. That realization quietly transformed the rings from timeless icons into temporary features. Saturn may have spent most of its existence without rings at all, and one day, long after humans are gone, it may lose them again. Cassini's final images captured the rings in extraordinary detail, revealing ripples, waves, and disturbances caused by gravitational interactions with moons. These were not static structures, they were active, evolving systems slowly unraveling. The rings became a countdown clock, marking a phase in Saturn's life that happens to coincide with ours. There is something deeply humbling about that. Humanity did not arrive at Saturn during its most stable phase. We arrived during a fleeting one. Cassini and the question of life. Although Cassini's final images focused on Saturn itself, the mission's broader legacy cannot be separated from the question of life. Cassini showed that Enceladus contains a global subsurface ocean with chemical energy sources that could support life. It showed that Titan hosts complex organic chemistry, with lakes, rivers, and weather systems eerily reminiscent of Earth. These discoveries changed how scientists think about habitability. Life no longer seemed confined to warm, sunlit planets. It could exist beneath ice, in darkness, driven by chemistry rather than sunlight. This realization gave Cassini's ending additional weight. The spacecraft was destroyed, not because it failed, but because it succeeded too well. Allowing it to drift uncontrolled risked contaminating environments that might host life. Cassini's death was an act of protection. That fact alone elevates the mission beyond exploration. It becomes a statement about responsibility. Humanity chose to destroy a functioning spacecraft rather than risk harming worlds it had only just begun to understand. The moment the signal disappeared. When Cassini's signal finally faded, there was no dramatic explosion captured on camera. There was no final image of fire or destruction. The spacecraft transmitted until atmospheric drag tore it apart, bit by bit. Engineers watched the data stream degrade in real time, knowing exactly what it meant. Cassini was gone. The mission ended not with spectacle, but with silence. And that silence lingered. For years afterward, scientists continued analyzing Cassini's data, extracting new insights from information gathered during its final moments. Even now, some of Cassini's measurements remain unexplained. Saturn still holds secrets that Cassini glimpsed but could not fully unravel. In that sense, the mission did not end cleanly, it ended mid-conversation. The final images are not conclusions, they are open questions. Why we won't see Saturn like this again soon? There are no immediate plans to send another orbiter to Saturn. Future missions are discussed, proposed, and debated, but none promise the sustained, intimate exploration Cassini achieved. Cassini was a product of a specific moment in history, when budgets, ambition, and patience aligned. Replicating that alignment is not easy. Saturn will continue changing, its storms will evolve, its rings will thin, its moons will remain active. But for now, humanity has stepped back. The last images Cassini sent are not placeholders until the next mission arrives. They are, for the foreseeable future, the closest looks we will have. That reality gives them a strange permanence. They are not just records of Saturn as it was, they are records of how close we once dared to go. What Cassini ultimately taught us. Cassini taught us facts, measurements, and discoveries, but it also taught something less tangible. It taught us that understanding is always temporary, that proximity reveals complexity rather than certainty, that the most meaningful discoveries often arrive when we are willing to take risks, even at the cost of finality. Cassini's final images of Saturn are stunning, not just because of what they show, but because of what they represent. They capture a moment when humanity chose curiosity over safety, responsibility over possession, and understanding over permanence. Cassini did not leave Saturn unchanged, it changed us, and when the spacecraft disappeared into Saturn's atmosphere, it carried with it the quiet acknowledgement that some opportunities, once taken, will never come again.